Hi, welcome to the Strayos Academy. My name is John Lewis, and I am a solutions engineer for Strayos. Today, we're going to be talking about stockpile measurements and how to visualize them within the platform. First, we'll want to navigate to the data set in which we are looking to analyze. In the platform, there's more than one way to do these calculations. We can either go to the inventory module, or we can simply just click on the polygon tool up here. From here, we will just kind of outline the outside of our stockpile. We'll give it a name. We'll call this stockpile 1, and we'll just give it a color. So now if we go to the annotations, we can see all of our annotations here, as well as our specific stockpile. So within the platform, Strayos allows for 3 different volumetric calculation methods and 5 different bottom reference elevation calculations. So the first one is the 3D model, and the 3D model is a high quality reconstruction of the surveyed area generated by stitching together the images captured by the drone. It's a very good way of calculating volumes. Another methodology is the digital surface model, or DSM, and this is a computer-generated representation of the terrain surface. The DSM takes into consideration the objects on the terrain like cars, conveyors, buildings, trees, vegetation, and other equipment. This provides an accurate elevation values with more resolution and therefore provides accurate volume measurements. The only drawback to the DSM is that it does take into account conveyor belts. The DTM does not. So essentially the DTM differentiates itself from the DSM by actually scrubbing conveyor belt information. So if we were to create a stockpile in this location, a DTM would actually eliminate that conveyor belt from spiking the volumetric information. So here we have the fill and the cut, and then the net from here. And obviously the fill should be a very low calculation. So for the bottom plane elevations, we have the lowest fit, which means it's a horizontal base plane at the lowest elevation of the boundary points. And this is the most commonly used type for stockpiles that are heaped against a bench or other objects. It will set the bottom horizontal plane at the elevation of the lowest point that's been clicked. So whatever the lowest point here is, it's going to set that. For manual, this allows us to enter custom elevations, grade, and azimuth values, and we can also, rotate and directly select things on the model. So if we didn't want to enter anything here, we can select on here. We can see the 3D visualization of our stockpile, but if I wanted to rotate, I could click and then just move it. And as you can see that intersection there, double click it, and there's my elevations, grade, and azimuth, and it's going to automatically calculate that. So this helps with stockpiles that are on different planes that we want to set manually. Linear fit is the best method for stockpiles which have clear boundaries and they're located on a flat ground. It's going to generate a best fit plane from all the clicked points and calculate the volume based on that plane. We also have the triangulated fit, and this works for large and long stockpiles. It's going to run a triangulation algorithm on the polygon and calculate volume based on those base planes. The base plane is not a single plane, but a set of triangles, as the name entails. Average fit works for stockpiles which sits on a flat ground and have clear visible boundaries. It sets the bottom plane as a horizontal plane with an average elevation of all of these clicked points. So we can also convert to inventory, which we will discuss in a later module. But also within this, there's the option to compare volumes to previous data sets. We will show that by just first going into the inventory, selecting a workflow, create, and let's just navigate to that inventory dashboard. We'll go down. There's our stockpile 1. We'll just go to one of these previously created ones. And you can see that you can select projects that you've previously done. Another tool that we allow is to copy stockpiles. So as we do flights in the future, if we were to segment out every different stockpile here, and those stockpiles don't change because this is a stationary conveyor belt, as we do month-end flights or weekly flights, we can actually see the changes in those stockpiles, how much material's gone out, how much material's come in. So once everything is complete, we can actually generate a stockpile report PDF, and that's going to have the high-level information. So that will be the boundaries of each stockpile, the names, materials, volumes, densities, tonnages, and total values. So right now, we just are looking at the volumes, and once we input the information outside of the volume calculations, this will be shown to calculate all this, and we'll talk about that in the next video. So I hope this information proves beneficial. If you want more information on how Strayos can help you, please navigate to our website, strayos.com. The link is in the description. Stay tuned for the next video. Thank you. Goodbye.